Okay, so I had the kids line up from shortest to tallest, and I know you can't see it at home, but it's something like this, from the shortest kids to the tallest kids. And I did guys separately from girls because otherwise it ends up being most of the guys are at the tall end and most of the shorter ones end up being the girls on the short end. And besides, it'll throw off our data if we don't do it this way. So now I got the guys on the one side facing the girls on the other side, and I want you to try to figure out who is the middle girl. Talk amongst yourselves, try to figure out who's exactly in the middle. And the guys, same thing, figure out who's the middle guy. Who is exactly average? Don't just guess. Do it math-wise. It's a good question. All right. So there are 12 girls. So who is the middle girl? Excuse me? Excuse me, you're going to be leaving soon. Thank you. All right. So we have 12 girls. So who is in the middle? All right. So there are 2 girls that are exactly in the middle, and they're about the same height. So you guys together are the average girl. All right. Now, over on the guys' side. Did you guys count how many you had? So you had 18 of you, so you're taking which one? Out of the numbers, the 9th and the 10th. That makes sense? That's right in the middle. Okay, so it's right between these 2 guys. All right, so you guys are the average guys in this class. Now, if you're going to compare yourself to the average, of course, you know, if you're a girl, you're going to compare with the average girl, and the guy would compare with the average guy. You're either taller or shorter than him, okay? And how much shorter or taller you are is called how much, this is all about standard deviation, and so it's how much you deviate from the middle, or the average. All right, so now I want you to, you guys that are in the middle, how tall are you about? Do you know? 5'10"? Okay, so 5'10's right about in the middle for the guys. How about over here on the girls? Okay, take your shoes off, both of you. We'll see who's taller. Yours are so thin that probably doesn't even matter. Oh, you have a heel on there. Yeah, that's okay. All right. Yeah, you're about the same. And how tall do you think you are? And you think you are? You've grown. You're 5'5". Deal with it. Okay. So, if you're 5'5", then if you're a girl who's like 1 inch taller, then how much do you differ from the norm? 1. Okay? I want you all to figure out how much you differ from the norm. If you don't know, walk up to the normal and compare them and see, like, okay, a couple inches, 3 inches? Ask somebody near them. If you know how tall you are, you can do it with math. It's easy. Okay, everybody back to your seats. Have a seat. Sit, sit, sit. Now, what we're going to figure out here is just deviation from the norm is like how much you differ from the norm. The normal in our class for guys was about 5'10", for girls was about 5'5", and that's why we did it separating girls and the guys, because there was a 5-inch difference between the normal guy and the normal girl. Okay, so then if you're a little shorter than average, again, that's okay. This class has some really tall people in it, so if you're a little taller than average, there's some advantages or disadvantages to that. Okay, so one thing that's important here is that for you to understand, are you guys as a group about the same heights as each other? In other words, would your standard deviation be small? Or are you guys pretty diverse? Like, is there a big difference in height between your smallest and your biggest people? Okay, do you think your group is pretty diverse and therefore would have a large standard deviation? Or do you think your group is pretty homogeneous and would pretty much have a very small standard deviation? What's your gut feeling about that? Yes. Oh, that was interesting. He said the girls didn't seem like they had as much difference between them. They would have a smaller standard deviation then, right? Between the guys, or compared to the guys. We have a theory on why that is?
I know.
What do you think?
Because girls grow earlier than guys.
Ah, so you're saying that by freshman year, a lot of the girls, these are all freshmen, by the way, if you're listening at home, if you're a freshman girl, you probably have already had your growth spurt, so to speak. That make sense?
Because
I am recording. It's just off the side of the screen.
they said like even guys can start growing in college.
You're right. For an example, Michael Jordan, when he was in his high school, his senior year, okay, so you picture that's 4 years older than you. His senior year, he had not hit his growth spurt yet. And so he wasn't even a very good basketball player in high school. And he became one of the best basketball players in history because he grew 9 inches from his senior year in high school to the end of college. Okay? 9 inches. Isn't that crazy? So the point is, you just never know. You might feel short right now and like, oh, I'm stuck with who I am. Or you might have already got your growth spurt and you might not grow anymore. I stopped in 8th grade. I was as tall as I am right now in 8th grade. And then that was it. No more growth for me. So you just never know. I remember I was way taller than some of my friends, and I would like tease them about, like touching the ceiling, like I could get, I could touch that, and I could touch things, jump up and touch things that they couldn't even get close to. And then the cruel joke was both of those friends, who were significantly shorter than me, grew to be 6'4" and 6'5", and I was still 5'10". So one of them could dunk, and the other one could close to dunk, and I was hopelessly left behind. So you never know. All right. So let's talk about in Japan. I told you my trip to Japan, I noticed that all the people seemed to be about the same height. It was just like everybody was about the same in Japan. Okay, now that's not completely true because there are sumo wrestlers. And the sumos were huge. They were usually really tall and really wide guys. And there were also, there's differences, but the differences weren't as big. So that means their standard deviation would be small. All right. In the United States, we're more of a melting pot. We got all different kinds of races. We got all different, sizes of people, and so we definitely have a high standard deviation. All right. Hope that helps you understand what that is. Now, I want to get you into the stat button on your calculator. Everybody, please push the stat button on your calculator, and I hope the thing that comes up is this screen right here. And I want you to go in there to edit list 1. So you just hit enter and it'll go into edit. And make sure you have some numbers on your list 1. Don't even care what they are as long as there's some numbers in there. An L1. Doesn't have to be the same as mine, just whatever numbers, as long as there's some numbers on L1. Then, if we want to do some stuff to that, you go back to stat. And then you can calculate. That's where you do most of your things. And one of the best things we can do is one variable stats. Okay, and if I hit one variable stats and then I hit, it really is asking me which list do you want me to use. If I just hit enter, it'll assume I mean list 1. Okay, so I'm just going to hit enter. And there's my one variable stats for my list 1. If you happen to have the same data we had in yesterday, it might look the same as this. But then I just wanted to remind you what these mean because you're going to need them today. This one is what? The average. The X with the bar means the average. Do you remember what the little squiggly sign meant? Sum. So the sum of the numbers in my case was 23.7. This one's also handy. It's how many numbers did you have? And I had 4 numbers on my list. N equals 4. And then the standard deviations are both of these. Those are both standard deviations. Why are they different? Because one of them is assuming that the data you've given the calculator is just a sample, not all of the data. And the other is, if this is all of the data you're going to give me, then that's the standard deviation. But a sample standard deviation is calculated slightly different than the normal standard deviation. So basically, we usually use S. That's the one we're going to usually use for standard deviation. But the one underneath it is technically also standard deviation, and that's if you give it every single piece of data. All right. Now, if you arrow down on this, do you see that there's more stuff here? Arrow down and see the other stuff you can find out. Minimum, and then what's this Q1 thing? quartile 1. That comes from one of those box plots. Remember making one of those yesterday? What's med? Median. If you wanted to know the median, 5.95. Is it possible that the number 5.95 is not even on the chart? Yeah. Then what it's doing is averaging the two middle numbers that were, if there's two numbers that are in the middle, it averages them. Okay? All right, arrow down again. And you got max, so that's pretty easy. That just means it's the maximum, the biggest number on the list. All right. Okay, so one variable stats is a really powerful thing to know. Now, let's talk about box plots again for a minute. I'm going to go, I've got a nice one here on my graph. Okay, I think you know that the very top, the end of the whisker there, that's the maximum. That's the max, that's the min. But which of these guys are what? Do you know what they are? All right. And that's what you need to learn for today's homework, because today's homework looks like this, and it has a box plot, and then it's like, what's the high score, what's the low score? That's really easy. But then what percent of the class scored above a 72? Well, you need to understand box plots to be able to do this. So, everybody stop, shut your iPads, look up here, and I'm going to give you the last things that you need to know. Shut that. Thank you. I know it's off, but shut the lid on it too so it doesn't get tempting. All right. This is the bottom 25% of your data. This is the top 25% of your data. Like, you guys probably know that you used to do rank in class, and you could know what percent you were. I was, me personally, at my high school, I was in the top 10%. I was the very lowest of the top 10% of my class. Okay, and this would be top 25%. This is the next 25%, and this is the halfway point right here, because that person would be the what? Not the average, the median. So this box plot thing is all about finding the middles. Obviously, you got to know what the smallest and what the biggest. This is, let's say these are scores on a test, and somebody got a 38. Ooh, pretty bad. And the highest it was like 102, must put extra credit on the test or something. And then, what's that one? It's the middle of the whole group. What's this one then? That's Q something. There's Q1, there's Q3, Q2, and Q3. Now let's go back to that list and see. Look on your graphing calculator again. And what did they give us again? Q1 and 3? Yeah. All right. So this, let's look at the Q2 number. Where's my calculator? Here we go. So I'm going to go back to stat, and we should be able to figure out for sure which one's which based on just looking at these. Where's my stats again? Let's calculate one variable stats. And if I'm looking for that Q1 is 5.8, and the median is 5.95, and the Q3 is 6.05. Those three numbers there, do you get that those three numbers would be this, this, and this? So this one's Q1. There is no such thing as Q2. Instead, we call it what? Median. The median. But if there was going to be a Q2, it would be right there. And then how about this one here? Q3. Okay, and this one's the median. All right. Again, I don't have the same data in here, so these numbers aren't the same, but at least they're showing you here that you don't need the Q2, because that's this one. And then you add a Q3, and that's the third one. All right, so I hope you're getting that this is the middle of the whole set of data, and then this is the middle of the bottom part. The bottom 50%, that's the middle. And this is the middle of the top 50%. Here's the top 50%. All right. That's how you read this graph. So, from here, it's just answering questions about these box plots. So I think it's going to be pretty easy for you. I'm going to look a little farther into the worksheet for it with you. We have just more questions about reading these things. It's pretty obvious that TV time is significantly higher than homework time, which is actually true in the real world. That's, you know, a lot of times we spend a lot more time on screens than we are on homework. And in certain countries, they do a lot more homework than they do screen time. And those countries might end up surpassing us. If you think about it, if you've got countries where their kids are like studying and learning more and more, and we're just getting entertained, it'd be interesting. It'd be interesting to see if that argument that, oh, they'll just be robots that aren't creative will really hold up. I mean, it's easy to say that, but will it be true? I'm hoping that we in this country don't lose our work ethic, because if we can't work hard, the countries that can work hard will overtake us. We have to keep hard work and we have to keep creativity. If we keep both of those things, then our country has a great future. We're willing to work hard and be creative. We'll have a great future. All right. So I'm going to ask you to do up to number 25 today and no more. Okay, so don't go ahead, because I'm not going to assign it the next day. I hate to torture the really smart kids who want to like be extra overachievers and you go do the whole thing and then I never assigned it. Okay, I think I'm only assigning up to 25, period. And 25, it says write a short paragraph. I'm fine with you writing a couple sentences. This is hard enough to write on the iPad, much less to write a whole paragraph. So a couple sentences ought to be good. So up to number 25, and that's it. Okay? All right, that's your homework for tonight. You got a bunch of time to work on it.